all the discords for just like class.
I think I.
No, it's like it's really big. It's not like a server. It's
That's what it's
like so much time. It's last quarter, and
it's fine because I can share. I can
something like that for it's like all the so
let's do that. I'll share with them.
yeah. Yeah.
And this one. What's up, everybody? And hope you guys are having a good Monday. Hope I don't interrupt Tuesday. Yeah, it's just been that kind of week, and it hasn't even started yet. So thank you guys for coming out to our next topic of the quarter, which we'll be talking about convolutional neural networks today. Pretty much for today, what I want to do is if you guys, just a show of hands, have you guys ever heard about convolutional neural networks before? What they do? Like any, yeah, maybe ish. Yeah. Yeah. That's awesome for those of you guys who do know what it is already. For those who don't know what it is, and its applications, that's what I want to go over mainly today. And then in the end, it will mainly be about you guys seeing an application with it, which is through image classification with two kinds of images. Is the person happy? Is the person sad? So what I'll do at the end of my slides here is I'm going to walk you guys through the project, and then I'm going to share you guys the training images from Google Drive to you guys. I'll put it in the Discord, and then from there you guys can take it, add it to your drive, and then it should work perfectly. The entire point of this, I don't want to spend too much time up here explaining and talking. I want you guys to actually do the code and actually see how it works. Majority of the code will already be done for you. It's just about creating the model, testing it, and seeing its accuracy. As far as any announcements go, we'll be having our next speaker event next week. I believe it is Professor Luca de Alfaro, who will be coming to the club next Thursday in person from 6 to 7 here at E2 180, so don't miss out on that. That'll be a really fun night for all of us. As far as the sky's no limit, Jonathan, I know you have your office hours coming up in a couple of weeks. You'll make an announcement on that. We will be redoing, we have the competition going on right now. Our theme is currently Brain Teaser. If you guys need a refresher on that, as far as winnings at the end, we still need to figure that out. And for those who are either who won it last quarter and who are waiting, it is coming to you. There's just been a lot of red tape that we had to get through in order to get to the point where we can actually start handing out the prize money to you guys in the form of gift cards. So it is coming to you guys. Just got to be a little bit more patient with us. It is coming to you guys, I promise. So with that being said, let's get started. So convolutional neural networks, what are they? So what I want to do is I want to kind of make this more of like a collaborative. So take some time, talk to the person next to you, talk to the people around you. What do you guys think, based on what you've heard, what do you guys think a convolutional neural network is? Where have you heard it being used? And what do you guys think it is? Yeah, I'll give you guys a minute or two. Talk with each other. All right. What do you guys think? Show of hands, or not show of hands, but like, who wants to volunteer? What do you guys think the CNN is? And yeah, or I'll just pick someone out. No one? No takers? None at all? I saw you guys talking. You guys were talking about something. Um, anyone want to take it? No? All right, that's fine. So a convolutional neural network in its basic sense is, at least the way I like to view it and the way you guys are going to be using it, is especially when it comes with image classification and determining and extracting features from there and making predictions and observations based on that, right? And from there, what do you want to do with that is up to you, right? And next slide. Perfect. So applications, that's the biggest thing that I want to kind of talk about, and what I want you guys to see is applications. Obviously, you can see in this image, like, all right, you can identify the different kinds of cars in the project that you guys are going to be doing. Is a person happy or sad? In a more technical way, if you have done some like of like research into like a general adversarial network, some of the discriminators and generators are actually convolutional neural networks themselves. So this neural network has applications just outside of images. But I want to see from you guys, what other applications of CNNs do you guys think there are? Show of hands. What's up?
I know it gets applied to like take this identification for the research, but that's what I see.
Right. Yeah. Yeah, absolutely. Anything else? Solid. All right. That's fine. Actually, Tesla's autopilot runs mainly on CNNs, and the controversy is, why are they using CNNs when there are other sensors that they can be using and that can make it more safe, right? So is a very small in what you guys are doing. Like, all right, is it this? Is it that? Is it fake news? Is it not? Whereas it has huge applications when you actually look at autopilot and really detecting like, and all right, is it an obstacle? What decision does the car need to make based on that? Like, is it a person, or is it just like a like something on the side? Is it a sign, right? And what does that mean? Can you get information from that, right? So they're bigger applications than just what you guys are doing here, and hope you guys could see that too. So how does it work, right? So I wish I could say that it was magic, because it really does feel like magic, but it's not magic. But I won't bore you guys with a lot of the math. What I will do is I will give you guys a high level overview of it, and then based on what I kind of talk about here, if you guys have any questions, ask me. And if not, then hopefully you guys don't need enough. You guys will not need to know the math for the project. It will mainly be just based on the layers of a convolutional neural network and how they kind of flow together. From there, you guys should be able to do the project, and it should be smooth. You guys should not need any of the math. So let's go to the first one. Sweet. All right. So your first layer in a convolutional neural network is the convolutional layer, where it gets its name, right? So how does this work? Very basically. Do we have the laser pointer? Sweet. All right. All right. So in a very high level way, all we're doing is we're taking some kind of filter, right? We want to extract features from the image. So let's just say this is an image that we fed into our convolutional neural network. So what we want to do is we want to extract all the features that we get out of it from this like matrix here. So what we're going to do is we're going to pass, in this example, we're going to pass a 3x3 array through it. And what you guys can do and decide in this project especially is what like stride length. So how fast do I want to iterate over my image? And what that's doing is, okay, I'm going to take this 3x3 filter. I'm going to pass it through my matrix here. I'm going to take the dot product of each one. And so I can extract all the individual features from my image into in this convolutional layer. Any questions on that? Basic so far? Yeah? Awesome. Next slide. Yeah, you're good. All right. Oh, wait, I can do this. Oh, hold on. Ah, it's not going back. Oh, no, I'm going the wrong way. Ah, okay. All right, so next layer is going to be our ReLU layer. It's mainly just an activation. So if you take, keep going the wrong way. Keep going the wrong way. If you take this from our convolutional layer here, what we want to do is we want to eliminate all of our negative values that we get. And the best way to do that is with a ReLU activation. And what ReLU does is it says, all right, if it's greater than 0, then keep it. If not, set it to 0, right? That's all we're doing. We want to just extract everything we can out of the image so it's easier for us to make decisions off. All right, so keep going the wrong way. All right, from there, what do? Now we really want to get the main features from it. So in our pooling layer is what is called a pooling layer. What we want to do is, it's very simple. All right, we're going to pass a filter and we're going to say it's a 2x2 and we're going to take a stride of 2x2 as well. So in this 4x4 matrix, if I start in the upper left, I'm just going to take the maximum value in my matrix in this filter array, and I'm going to create it into my 2x2. So here I'm going to take 9, here I'm going to take 7, here I'm going to take 8, and here I'm going to take 6. All right, so you're just getting the main features from your image, right? And any questions on what I've gone over so far, by the way? Yes, no, maybe so? No? All right, cool. And I'm going through this a bit fast. I want to get to the code because I feel like that is a better representation of what I can explain up here. And if you guys do have any questions once you look at it, like this is all Greek to me, that's fine. We'll walk through it all, and hopefully it will make more sense. So last but not least, but second to last, what we want to do is we want to flatten our, let's say our 3x3 array here into just a 1D array, right? What we want to do is, the reason we're doing this is so that we can pass it through our fully connected layer right here, right here, and we can make decisions in the end. Is the person happy? Is the person sad? So you're passing through your flattened layer right over here as inputs into your network, and then your output is a person happy or sad? Is that a person? Is that a car? Is that a bird? Is it a plane? Whatever, right? And you want to classify those images per se, right? So any questions on that? Yes, no, nothing? Cool. All right, so that's in essence how a convolutional neural network works. It's very basic. I did that on purpose. I don't want to explain any of the math to you guys because I don't feel like you're just going to be bored. So with the code, I hope it's more exciting. So I want to walk through it. It's probably just better up there, right? Yeah. All right. So so the first thing I want you guys to do is open up the tiny URL link, and then I actually need to make a change. Hold on. One second. Just coming through. I don't know if yeah. No. I'm checking if I did. Okay, cool. Okay.